rule we mentioned in section 4.2 is the addition rule for two events, for any two events. We said that probability of E1 union E2 is equal to probability of E1, close the mic please, Shabab. Probability of E1 plus probability of E2 minus probability of the intersection. And we studied one example, which was this exercise. And let us now go and solve another exercise. Suppose that we have a sample space with 6 equally likely experiment outcomes. So these are equally likely outcomes. Here, this is the sample space. We have 6 outcomes in the sample space. A is a subset, so it's an event. B, C are events of the sample space. Find probability of A. To find probability of A, you count how many numbers in A. There are 3 numbers and 6 numbers in S. So the probability of A is half because the experiment is equally likely. Also, probability of B would be 3 over 6, which is half. And probability of C, because C has 4 elements, outcomes, so the probability would be 2 over 3. So these are the probabilities of A, B, and C. Now find probability of A union B. To find the probability of A union B, I can use the formula, okay, or I can use another method, which is the following. I can find A union B first. Think of A union B. This is A, this is B. What is A union B? A union B means all elements in A or B. So all the elements in A would be in the union, and all the elements in B would be in the union. So from here, probability of A union B would be 6. I have 6 numbers and the sample space is 6. So the probability of A union B is 1. If you want to use the formula, which is this one, the additive formula for two events, you can. It will give you the same answer. So probability of A union B according to the formula would be probability of A plus probability of B minus probability of the intersection A and B. Probability of A is half. Probability of B we found in part A is half. Now we need to find probability of A intersection B. So we need to find A intersection B. A intersection B are all the elements in A and B at the same time. If you look carefully, X is here, but it is not here. Y is here, but it is not here. Z is here, but it is not here. So nothing in common. So A intersection B is phi. Probability of phi is 0. So minus 0. So the probability of A union B would be 1. It will give you the same answer. So you can find probability of A union B either by this method or that method. Now, are A and B mutually exclusive? The answer is yes, they are mutually exclusive. And why they are mutually exclusive? Because simply A intersection B is phi, or probability of A intersection B is 0. Okay. Either you say probability of A intersection B is 0, or you say A intersection B is phi. This is a proof that these two events are equally likely because this, are mutually exclusive because this is the definition of mutually exclusive. Now here, what is the probability of B complement? This is B complement. Again, you have two methods. You can find P complement and find the probability of B complements, or you can use the formula. The formula says it is 1 minus probability of B, and probability of B is half, as we found in part A. So probability of B complement would be 1 minus half, which is half. Find probability of B union C. I will use the formula, although you can use the other method. It is probability of B, which is half, plus probability of C. Probability of C is 2 over 3, as we found in part A, minus probability of B union intersection C. So we need to find B intersection C first. This is B and this is C. The intersection, any outcome in common. You can see that we have U here, U in B and in C. So U in the intersection. Also W in B and in C. So W is the intersection while V is here but it is not there. So we have two elements in the intersection, which is U and W. Okay, U and W. Now, what is the probability of the intersection? How many outcomes? Two. What is the total number of outcomes? Six. So the probability of the intersection is 1 over 3. So the answer is 1 over half plus 2 over 3 minus 1 over 3. And this will give you 5 over 6. 1 over 3, yeah, 5 over 6. So this is the probability of B union C. Now, this is a special case. Now, probability rule 5, special case from the addition rule for two events. If the two events are mutually exclusive. What is the meaning of mutually exclusive? It means that E1 intersection E2 is phi. That's the meaning of mutually exclusive. So if the two events are mutually exclusive, then probability of E1 intersection E2 would be 0. So the probability of the union would be probability of E1 plus probability of E2 minus 0, the intersection. So it would be probability of E1 plus probability of E2. So if you know that the two events are mutually exclusive, like here, like A and B, so you don't have to find probability of the intersection because it would be 0. Let us take an example. A retail clothing store has three styles of work boots. Okay. They currently have 6 pairs of style A. So we have three styles, style A, style B, and style C. From style A, we have 6 pairs. From style B, we have 12 pairs. From style C, we have 2 pairs. Okay. If a store clerk randomly picks one pair, okay, we need to pick one pair to put on display. What is the probability that boot is style A or style C? So this pair which you are going to select, what's the probability that it's from style A or style C? So let me say that we need to find the probability of A union C. Probability of A union C would be probability of A plus probability of C minus probability of the intersection. But here, one boot, you can think that one boot cannot have two styles. Either the boot is from style A or from style C. So in fact, A intersection C here is phi. You can say boot cannot have two styles. Okay, so the probability would be only the addition because the two events are mutually exclusive. Probability of A. Now, how to find probability of A? What is the probability that the boot is from style A? How many boots from style A we have? We have 6. How many? We have 6 pairs. Okay, and in total, what is the total number of pairs? We have 6 plus 12, 18 plus 2, 20. So we have 20. Okay, so probability of style A, 6 over 20. Probability of style C, we have 2 pairs of style C over 20. So the probability of A union C would be 8 over 20 or 2 over 5. That's the probability. Let us take an introduction to the conditional probability. This is a very important type of probability, conditional. Okay, we will need sometimes to determine the chances of two or more events occurring either at the same time or in succession. Okay, succession. When we have succession, conditional probability will appear. Okay, for example, a quality control manager for a manufacturing company may be interested in the probability of selecting two successive defects, defective products from an assembly line. Okay, here we will have conditional probability. Why? Because when you select first defective, when one defective is selected first, now the second choice, the second selection, whether it's defective or not, depends whether the first was defective or not. Okay, you want the two to be defective, so you will say the probability of the first one to be defective, that's okay, but you need the probability of the second one to be defective given that the first one is defective. Here you have a condition on the second selection, and that's why we call it conditional probability. Or the decision maker might know that an event has occurred. Event has occurred. Okay, I know that an event has occurred, and may then want to know the probability of a second event occurring, given that the first one has occurred. Here also we have conditional probability. So what is the conditional probability? The probability that an event will occur given that some other event has already happened. Okay. So for example, if I ask you, what is the probability that you get 20 out of 20 in the exam today? And you say, for example, well, 70%. If I say to you, if you studied hard, given that you studied hard and the questions are similar to the lectures, in this case, you may say, okay, in this case, the probability would be 80 or 90 increasing. Okay, so this is a conditional probability. This is the notation. How to read this? It's very important to learn how to read this. This is a probability of E1. It is not probability of E2. This is probability of E1. We call it the conditional probability of E1. So it is the probability of E1. What is E2? It's something given. So given that E2 has occurred. Okay, so this is called conditional probability of E1. While if you write probability of E1 like this is unconditional probability of E1. So this is conditional probability of E1. E1 is written first, and this is unconditional probability of E1. How to find the conditional probability of E1? Okay, you find the intersection, probability of the intersection, over probability of E2, which is the condition. Okay, you divide by probability of E2, which is the condition, because it is given that E2 has happened, so we only divide by probability of E2 because we know that E2 has happened, and then we find the intersection between E1 and E2. Of course, probability of E2 here has to be greater than 0. We know that it is always positive, it cannot be negative, but it could be 0. If it is 0, we will not be able to find the conditional probability because we cannot divide by 0. But the probability of E2 here has to be greater than 0. Let us take this exercise, and it would be the last thing we do today, inshallah. A group of 750 people were classified according to their gender and smoking habits. So there are two variables, the gender, male, female, and smoking habits, smoker or non-smoker. The results are given in the following table. So 90 here means what? 90 means there are 90 female smokers. Okay, 315 non-smoker males are there in the sample or in the group. Okay, one person is selected at random. Find the probability that the selected person is a male or a smoker, or this is union. Okay, if I say male M, female F, smoker S, non-smoker capital N. So probability, he needs probability of male or union, smoker, which is S. I can use the formula probability of M plus probability of S minus probability of M intersection S. To find the probabilities, I need to add the numbers to find the total. So for example, here 210 plus 90, this is 300, and this is 0, 5, 450, and the total is 750 as mentioned. Also here, if you add, you have 5, 3, 2, 5, 525, and here I have 5, 2, 2. Okay, so the probability of M, number of males, I have 525 males over the total number, which is 750. Number of smokers, I have 300 smokers between females and males over the total number of people in the group, minus the intersection. Now, the intersection between uh, males and smoker is here. I have 210 smoke or males who smoke. Okay, so minus 210 over 750, and please find the answer. You can just add 525 plus 300 minus 210. The answer is 615 over 750, and then simplify the answer. Okay, of course you can find this probability using another way if you want. If you want to find this probability from the table without using the formula, he needs M or S. So you add these numbers plus this one. So 315 plus 210 plus 90 will give you 615 over 75 because you took all the smokers with the males, so it will give you the same answer. Okay, another question. Given that this is immediately conditional probability. So probability that given that the selected person was a female, so we know that she is a female, find the probability that he is a smoker. So we need to find the probability of S given F. By definition, this is probability of S intersection F over probability of F. Probability of S intersection F, let us see. This is F and this is S. I have 90. So I have 90 over 750. This is a probability of S intersection F over probability of F. I have 225 females, so probability of females would be 225 over the total number, which is 750. 700 cancels with 700, and then the probability would be 90 over 225. You can find this probability also in another way, immediately from the table. How we do that? Uh, the, given that female, given that female means you concentrate on females. Only you look here to the females, okay? So I have 90, 135. And then what is the probability that she is a smoker? So you look to the smokers. So 90 females smoke. So 90 divided by the total number of females, which is 225. So you can find the probability like this 90 over 225. You took the smokers of all the females. Okay, that's the probability of smokers given females. Finally, the last probability, find the probability that the selected person is a female and smoker. And means intersection, female and smoker, 90. So female and smoker is just he needs probability of female and smoker. This is 90 over 750. I stop here and I open the floor for questions. Please, if you have any question.